This video will cover view selection. I'm assuming that you've already done Lab 3 and you're familiar with the 6 views, the 6 orthographic views available to you in a multi-view drawing. Typically, we don't draw all of them. In most cases, 3 is sufficient. The standard is to include the front, right, and top views. The rest of the views, especially in the case of this example, are actually redundant. They don't carry any information that the top, front, and right views contain. So when we really go to draw this part, and we're not just practicing envisioning views, it's going to look more like this. This is called the third angle projection. Note that you get to make a choice in what you define as the front view. Ultimately, that choice defines what the right view and the top view will look like. So choose wisely. Usually we choose the front view to be the view that carries the most information. Or, another way of saying it, a view that has the fewest hidden lines. Ultimately, it's a judgment call. Remember, drawing is a communication exercise. You want to pick the front view, and thus the right and top views, that make it the easiest for the person who's reading your drawing to understand the geometry. Of course, 3 views aren't always required. Sometimes fewer views are adequate. Here's a 3-view drawing of a flange for the robot in the manufacturing lab. We have the front view, right side view, and top view. Notice though that because of the particulars of this part, the top view doesn't really add anything that the right side view doesn't. The right side view conveys the threaded protrusion, the counterbored holes, and the locating pin hole. The third view really isn't adding anything. And so it is quite correct and best practiced to delete it. It unclutters the drawing, gives more room for notes and dimensions, and just makes the drawing easier to read. There are also cases where you certainly would want to include more views than the standard, or at least different views than the standard. This is an adapter flange for the UR10 robot in the lab. There are 2 parts here, the adapter flange for the robot and the adapter plate for the gripper. We'll focus on the adapter flange. Note here I have chosen this view as my front view, and I've elected to give the left side and back views. I've gone against some of my own advice. My front view has more hidden lines than my back view does, and essentially the front view and the back view have all the same features. In truth, they are redundant. But I did this for the simple reason that I had a lot of dimensions to put on this drawing. To try to put all of these dimensions and notes and all of these dimensions and notes on the same view would be extremely crowded and extremely hard to read. That's why I chose a front and a back view. Note I did not include a right side view because it really wouldn't say anything that the left side view doesn't. Likewise, top and bottom views would be redundant. I've also gone against the rules a little bit in that I have not shown the hidden lines in the left side view. If you envision what all of these hidden lines would look like for all of these features that protrude through the part, the hidden lines in this view would just be a mess that's very, very hard to understand. Again, remember, drawing is a communication exercise. Just because it's technically correct to put the hidden lines in here doesn't mean that you necessarily should. Also, another thing to think about when you're picking views is to think about the orientation of your front view. Remember, that will define what your other views look like. Notice in this drawing, I have the locating hole located at 0 degrees, or in the X direction. This places the hidden lines for that locating hole separate from the hidden lines for the counterbore holes. This certainly wasn't my only choice. In this version of the exact same drawing, I have the locating hole at 90 degrees, or in the Y direction. This causes the locating hole hidden lines to overlap with the counterbore hidden lines. It's technically correct, and an experienced person can understand, looking at the two views, which hidden lines belong to which, but it's just a little bit harder to interpret. It takes a little bit more time. Here's another version. Now I have the locating hole oriented at 45 degrees. Again, we have the same issue with the locating hole and the counterbore hole overlapping. We also have an issue here. These hidden lines, here and here, refer to the minor diameter of the thread on this feature. They happen to line up with the hidden lines associated with the counterbore for this hole and this hole. Again, it's technically correct, and a person who studies the drawing long enough will realize that this note tells them that this is a thread. But it would also be very, very easy for somebody quickly looking at the drawing to think that there is a blind hole, or a hole that doesn't go all the way through the part, that goes through this feature and all the way through. It's a little ambiguous in that sense. Again, best practice is pick the views and pick the view orientations that are the most clear and the easiest to understand. It's a judgment call, but in my opinion, this is the easiest to understand. I can't emphasize it enough. Creating multi-view drawings is an exercise in communication. Just like any other form of communication, speech, writing, you're going to pick the best, most clear words, phrases, sentence structures to bring your point across to the reader or the listener as quickly and as easily as possible. The same is true with drawings.